Yes. Okay. So let us start. Is the presentation visible? Is the presentation visible?
Yes, sir.
Okay.
Sir, it is.
Good. Good. So uh, we had started discussing about operator overloading. Our intention is to be able to create user-defined types which behave pretty much similar to the way the built-in predefined types behave. So we want to overload various operators that are available for predefined types for the class that we are defining for the user-defined type, so that in a similar manner as the predefined built-in types, we can write algebraic expressions of our intended UDTs, user-defined types. So we talked about such algebras for complex, for rational, for matrix algebra, for string algebra, and so on. Right, so we will dig deeper into that and learn the whole of operator overloading. We'll look at some of the issues which need to be properly addressed, and we'll specifically look at how to overload input-output operators. So just a quick recap from the last module. An operator function can be a global function, a member function, or a friend function. And just 1 second, just 1 second. Hello? Yes? I'm interested in knowing. Thank you very much. Sorry about that. Okay. So an operator function could be a global function, a member function, or a friend function. And for binary operators, we can have, for any type that I'm trying to build up, say my type, it could be a global function taking two operands for a binary operator by constant reference and returning a result of the my type by value, because it is a new object that needs to get created. Or I can define it as a member function, in which case on the signature of the operator, I have to pass only one operand, the right operand by constant type. The left operand is the object itself on which this member function is invoked. Or I can also define a friend function, which is some global function which I make friend of this class. Similarly, I can do for the unary operators as well. So if we define global function corresponding to the operator plus, then a plus b will be interpreted as operator plus ab, matching the signature of the global operator function. Whereas if I define the operator function as a member function of the my type class, then a plus b is taken to be a dot operator plus called on b. This particular understanding of the syntax between the infix and the prefix is very important, because you will always note that out of the two operands, the left operand will always be used to invoke the operator if it is a member function operator. So in a plus b, it is invoked on a. So a dot operator plus. So the address of a goes as an implicit this parameter in the member function operator, and the right operand, the second operand, goes as a parameter. Right. So that's a basic principle. Now let us again consider the complex class for which we have seen operator. We have learned how to overload the operator to add two complex numbers. And with that, if I have constructed D1 and D2 as two complex numbers and D3 is some result complex number by default, then I can always do D1 plus D2, which will invoke the operator plus for the complex numbers and add them in the complex and then assign the value to D3. Obviously, I will also need to overload the assignment operator so that this assignment can also be valid. Now, suppose I want to extend this operator so that a complex number and a real number can be added together. A real number is a special case of a complex number. It is a complex number which has the imaginary part, which is 0. Now, there could be two ways of doing that. One is from that real number, I can construct a complex number object and then add. Obviously, that is possible, but I have to write more code. But I would like to be more intuitive to say that if D1 is a complex number and 6.2, as you can see, is a double constant, I should be able to write D1 plus 6.2. My operator should allow that. So what will mean that it is 6.20 is the complex number. So it becomes 8.7 J 3.2. I should be able to write this. Similarly, I should be able to write the real number as a first operand also, say 4.2. I should be able to write 4.2 plus D2. So in which case 4.2 and 1.6 will get added and 0 plus 3.3 will get added. Now, the operator that we have designed will not allow any of these to happen. Why it will not allow? Because it expects two double values, two complex values, two complex number objects to be available as parameters, and it will not match that parameter. So these kind of expressions we will not be, so which is very intuitively algebraic expressions you would like to write. So this will not be possible. So this is one shortcoming that we are observing. So let us see how to solve that. A second issue that we would like to address is, for the complex class itself, we would like to overload the streaming operators. The input streaming and output streaming operators are common for all built-in types, and they are very convenient to write input-output expressions. So if I have an object of type complex D, I should be able to write this, and that should do whatever I want to do in order to read or to print that particular object. So far, we have what we have done. We have provided, say, a kind of a display function or a show member function, which can write out the components when I'm outputting. But I would just like to make it in this kind of an algebraic infix operator notation. Right. So Cout is an O stream object, output stream object. Cin is an I stream object. I'll talk a little bit about them at a later point of time when we come to STL. But using that, how do I overload these operators? These are also operators. They take two operands. One here, the first operand is an O stream object. The second operand is a complex object. I'm sorry, in this case, Cin. So first operand is an I stream object. Second is a complex object. In the second case, first operand is a O stream object, and the second operand is a complex object. Now, what is the result of, say, doing Cout output streaming D? What is the result of this operator? The result of this operator is a new Cout object, is a new state of the Cout object. So that I get the output stream where the complex D has already been streamed. So I can again stream another object of complex type or built-in type or some other type onto that O stream object. Right. So that's what these are the two things we want to solve today. So let us see what is the solution. So we can extend the operator plus function as a global function. So what I have made is I have made the components of complex class RE and IM as public, and then I have given a number of operators. What I have done is operator plus function. I have now overloaded. This was the original, which had two complex numbers. Now I've given one which takes a complex number and a double. I've given one which takes a double and a complex number. So all three have distinct signatures and matches with the three forms in which I want to add the complex number with a complex number or complex and real numbers together. Right? So this solution should work pretty fine. Now here only one point you have to see, that I'm putting a new keyword before the constructor. Just look at this keyword carefully. This keyword is called explicit. What it means, it will take a little bit of time for you to understand. What it means is, if I write something like, suppose I did not have the two overloaded operators. If I did not have the two overloaded operators, I have only the first operator which takes two complex, and I'm trying to call it as D1 plus 6.2. Then what will the system try to do? System will try to do the matching. Right? Exact match is not possible. So it will see if a matching can be done by promotion. So with 6.2, which is a double constant, and the target type, which is complex, it will try to see is a conversion possible. And that conversion is possible by the constructor, because the constructor can take a double value and give you a complex number, because you have three overloaded constructors here, and one of them takes one double value only. So even if I do not provide the second overloading, the second line in this program will work pretty fine, and so will be the third line, because I can have promotion from double to complex. I do not want to use that mechanism. That mechanism has other consequences, type casting consequences, which I will talk about later on. So what I say is explicit. What it means, if I say explicit, then what it means, that no implicit use of the constructor, which is required here for conversion of 6.2 into a complex object. This is an implicit use, because I have not written any code which says that the constructor has to be used. No such implicit use will be allowed. So which means that once I write explicit, if I drop the later two overloads of operator plus, then D plus 6.2 or 4.2 plus D2 will not compile. So I'm trying to ensure that. I'm trying to ensure that safety. So this is a very important quality parameter. So with that, this will be a solution. But obviously, these are all global functions. They need to use RE and IM. So I've made them public. So what I have done, I have destroyed the encapsulation. So that is not a good solution in the object-oriented paradigm we have learned. So global solution is not the solution. Let's try to use the member function. Going to the next slide, slide 8. I have kept everything same, and I have actually, now it is a member function, so it takes one operand. So I have rewritten the operator plus by two overloads, one which takes one complex number. So if I do D1 plus D2, it will match this operator plus member function signature, and we'll call this. If I do D plus 6.2, for that, I have given an operator plus signature which takes a double. The object on which it is called is complex, the first object. The second one is a double I want, 6.2. So I have given a signature which takes a single double as an overload, so that this will get invoked. And internally what I'm doing is, when I get this double, I explicitly construct a complex object, complex BD. Explicit this there, implicit conversion was not possible because I had this explicit. So I explicitly construct a new object from this double value, new complex object, and then use the other overload as start this plus b. Start this will be of type complex, B is of type complex. So if I write this expression, this operator is actually the earlier instance of the member function operator. So it will then call this operator, and then it will be able to do the actual addition. Right? So this is a good member function solution. So up to this point, everything is fine. Think about now, D3 is 4.2 plus D2. Now you have a problem. I cannot write the third overload where the first parameter is double and the second is complex in a member function form. Why? Because the member function is invoked on the first operand, the left operand, and the left operand is of type double. So when I write 4.2 plus D, it does not look at overloaded operators of the complex type. It looks at operators of the double type, which certainly does not take a complex.
Sir, I guess you are not audible.
Yes, so you're not audible.
Am I audible now?
Yes, sir.
Yes.
I had
Yes.
lost connection. Yeah. So I'll share again. So presentation should now be visible again. So with member function also, so we saw that we cannot have operator plus overloaded with our intended requirement as a global function because it is violating the encapsulation principle. I cannot also do it as a member function because of the case that I have shown here. So let us try the third. Let's try friend function. So now it is still the data members are encapsulated as required. The constructor is explicit. This is like the global functions only, but I have made the global functions as friend. So when I make them friend, as you have known, then it is a selective access through the encapsulation. So now my state variables RE and IM are not exposed publicly, but this operator plus can use them. And now I have three overloaded operator plus signatures like the global one, and all three of these will work. And so this is a solution that you have if you want that addition must work with a double value being one of the operands, right? So this is what you'll do. If you do not want that, then you can just have a member function operator for two complex values, right? So, but we'll see that very often friend is used as an in case of operators, because you have these kind of issues of arising out of the fact that operators are always invoked on the left operand if they are member function operators. Otherwise, they are just by signature mapping. Global breaks the encapsulation. Friend does not break it in general. It just selectively accesses within that function. Right? We can have a simpler solution for this using implicit casting, which we'll talk about when we talk about type casting. But let us look at something more interesting. Now
Excuse me,
consider.
sir.
Yes, please.
Sir, in the friend function, the
Right.
functions have been defined within the class. So can I also define it outside the class?
Yes, yes. The function body you can define outside the class. What you
Oh,
need to write is signature
okay,
has to be
right.
within the class so that the class knows that this function is friend. I think we have had earlier examples in case of list and iterator where the function body was written outside. And when you do that, you'll have to remember that the friend function is actually a global function. So the name of the function will remain operator plus. It will not become complex colon colon operator plus. Whereas I'm going back one slide. Whereas for the case of member function operator, if you want to write this body outside, then also you are allowed to do that. But in that case, your operator plus will have a name which is complex colon colon operator plus because it is within the namespace of the complex class type. Right?
Okay, sir.
Now, now let us come to overloading of IO operators, which is very, very interesting. Suppose I have so two complex objects D1, D2, and I want to write this code, which is what we write all the time using the built-in types, predefined types, and we would want this to happen. What does this do? It first streams D1 to Cout, right? So if you look at the associativity of the output streaming operator, it is left associative. So this actually means this expression, that is Cout D1 output stream to Cout, and on that result D2 is output stream. So you can easily make out that the result of this streaming has to be the O stream object itself, the Cout object itself. Right? So what can be the what may be the signature of the operator output streaming? As a global function, its first parameter is output streaming, so it is waste stream ampersand, that is it has to be taken as a reference parameter, because certainly you do not want to copy that whole stream and there are more serious reasons. And the second operand is a double object, so you have to take that, I'm sorry, a complex object, so you have to take it as a reference. Now you certainly do not want that the output process should change your complex object, so you make this a constant, so you make it a constant reference. But how about the O stream? Let's see what will be the output of this. The output of this, as we can see, will be an O stream object. And you want the same Cout object to which you started output streaming D1, you want that same Cout object to be back. So you need that as a reference, need that to be returned as a reference. You do not want a return by value, because in that case you will get a new copy of the Cout object which will not serve the purpose. You want the same object back. Now since you want the same object back, which means when you write D1 to Cout, you will be changing Cout. So this first parameter O stream has to be a non-constant reference. It cannot be a constant reference because you will need to make changes to OS to actually write the components of D1. So this will be the signature of the global function. What if I write a member function? Now, if I want to write a member function, I have two choices, right? Because there are two classes involved. Earlier, I did not have two choices because one was complex, other was double. I could not have, double is a predefined type on which you cannot actually do any, you do not have any option of overloading. But here, complex is a class. Cout is a OStream class, which is also written by somebody. It is just that we are not writing it, but a library provider has written it. So it is also an object. Cout is also an object of the user-defined type, OStream type. So I have two choices. One is I can write it as a member function in OStream, which is the left one. So if I do that, then I will have the right operand, which is the complex object as the parameter. So I'll have const complex ampersand a, constant reference I pass, and obviously I get back. So I will return by start this, the way we did in case of the what was that copy assignment operator, right? We can do this.
So you're inaudible.
You can hear me now, right?
Yes, sir.
uh, I again lost connection. I don't know what goes on. So here is the slide. So if I put it as a member function in complex, it has to take the OStream object as parameter and also return that OStream object. So these are the three possibilities. So let us examine them in closer detail. So this is by global operator. So I can write it as a global function, OStream operator as well as iStream operator. So I take the complex object, I take the two components, write them out with a J in between. Or if it is an input streaming, then I will, for an input stream case, the complex will have to be a complex will have to be a non-constant reference because you are inputting. So you want this A to change to get the value that you have inputted. So you pass a dummy complex object here where you read the components RE and IM from the iStream, and then you return the iStream. Right? So this could be the two solutions for input and output. This will work pretty fine. Only problem is the original one, that it breaks the encapsulation. So we will not be able to use this. Now let us try to do this as a member function, and we have two options for the member function. So if the member function is in OStream object, then we have a nice solution. But the problem is OStream is a class in C++ standard library, and we are not allowed to edit that library for the simple reason that if everybody starts editing the standard library, it will get messed up. Right? So to be able to have this operator in the OStream class, I need to include this signature of the member function in the OStream class, which I'm not allowed to edit. So I cannot take this solution. So this second solution also is out of consideration. Let us look at the third solution. Can I make it a member of the complex class? So can I write the operator output stream like this? Well, I can do that because I have the object, I have the class in my control. But if I do that, remember that OStream becomes the second operand because the invocation is always done on the left operand. So if I write an operator like this, then the invocation of that will be D redirection C out. It gets unnaturally swapped. So this is also, so you'll have to write the whole thing from right to left, right? Completely non-intuitive. And this is not something that you will accept as a solution. So we come to the conclusion that operator output streaming or input streaming in the same matter cannot be written as member function. So I cannot use global, I cannot write member function. So the only option left is I can write the way we have written the global operator function. I can make them friend of the complex class. In that case, I do not need to break the encapsulation. I can make them friend and work with that. And that is the solution. There is no other solution which preserves everything. So I told that friend is a kind of breakage in terms of the encapsulation rule, but it is a controlled breakage. And there are cases like this one where only the friend function can give you an elegant, efficient solution to extend your design, right? So this is what we have learned. So whatever we discussed, I have put them down here as guidelines. So use global function when encapsulation is not a concern. Use member function when left operand is necessarily a class or a class object. Otherwise, use friend function as we have seen. While overloading, try to preserve the normal semantics. So what we mean is when you are overloading operator plus, that should do something which is kind of a sense of union or addition or something like that. So in complex, it should add complex numbers. In rational, it should add rational numbers. In string, it should concatenate strings. In matrix, it should add matrices. But you should not call something as operator plus and internally say, take two matrices and make their product, but call it operator plus. You are allowed to do that because you are defining the semantics of your operator, but it is not something which is advisable at all because that breaks the overall semantic uniformity for which we are overloading the operators. You must stick to the parameter passing mechanism. Built-in types can be passed by value, and user-defined types should be passed by constant reference. For output, of course, for input, it has to be non-constant reference. And decide on the return type based on the semantics for the built-in type. The basic rule is if you are returning an existing object, then you must use reference type. If you are returning a new object, like addition of two numbers or two complex numbers or two strings, then you must use a value type because that object did not exist. And consider the effect of casting. I'm not going into the details of that, but we will talk about it when we talk about casting. And also do not go overboard in overloading operators. Like, initially when you get to do this, since it's so powerful and exciting, you tend to overload every operator that is available and try to give some semantics. But in your domain, every operator may not have a semantics. For example, in case of say string algebra, comma operator may not have a semantics. So why overload it? So do a minimal design. The less you write, the less you design, the less errors can be there. And writing error-free code efficiently is always our target. So this is what we have learned about operator overloading. Let me stop briefly to see if there is any question on this part, on the operator overloading part. Otherwise, I'll move on. Why is it suggested that built-in types be passed by value? Ritoban, that's a very interesting question. You will get a complete answer for this when you get to the design of compilers, because it has to do a lot with the efficiency of the programming. See, if you pass something by constant, it is good by reference. It is good to think that you are giving it a alias name. But finally, at the implementation, somebody has to remember that. Somebody has to remember that address. It's only that difference with pointer is you are not allowed to access and manipulate it as an address, which you can do for pointer. But the reference still has to allocate memory where it puts the address. It has to access from that address and so on. So memory-wise, any reference use has an overhead in terms of the memory. So if you pass by reference, it will need that additional one. For a built-in type, you may not want to do that because majority of the built-in type, particularly the int type or variants of the int type, like short, char, and so on, they are sized in a way that they fit directly into the register of the memory. So if you pass them by call by value, then it is very likely that actually no parameter copying is done. Though it is called by value, there may not be any parameter copying required, because you may be able to just reuse the same register after you have stored everything of the environment. So it becomes a lot more efficient to use call by value for built-in types, because built-in types have properly aligned size in terms of the registers or register pairs and so on. So it gets a lot more efficient to do that, which is not true for the user defined types, because user defined types will have arbitrary size, and also very often user defined types are large in size, and you do not want to copy that whole thing and invoke the copy constructor, which has an additional overload for doing that and all that, right? So that is the basic reason that you use this principle, and that principle is a something like in assignment 1, I have always asked you to talk about the guideline. So this you can take as a guideline, which is a very good guideline, that when you are passing parameters, try to normally pass built-in type parameters by value, and user defined type parameters by reference. If you do not want changes there, use const reference, right? So that's the reason. Does it answer your question, Hirtavan? Okay, thank you. Is there any other question? No.
Yes, sir.
Yes, please.
Sir, inside the class definition, if we declare a overload for the operator plus, then it won't allow us to write more than one parameter. But outside of the class definition, it will allow us to write either 0 or 1 or 2 parameters also.
No,
So
no,
like,
no, 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 no. You will have to write, if it's a binary operator, you'll have to give two parameters only. Otherwise,
so
how will
sir,
that operator get invoked? See, you, you you can default a parameter. That is a different thing. If you default a parameter, that parameter is still there, right? But you are using a default value. But if you want to write an operator plus global function with just one parameter, it will not compile, because it will operator plus is a binary operator. If you use one parameter in the global as a global function, it will be taken as a unary plus operator. You're getting me?
yes, all right.
Because I said the basic principle of operator overloading is you cannot define new operator, you cannot change the arity of the operator, you cannot change the associativity of the operator, you cannot change the precedence of the operator. These are fixed, right? Otherwise the compiler will not even be able to compile. If you want to say that suddenly the division operator becomes a unary operator, the compiler will not be able to handle that, because there is no scope for doing this, right? And the deeper reasons of why this restriction, all those will become clear, crystal clear to you when you write the compiler in your next compiler course. Right? You'll be able to see really why these restrictions are there. These restrictions are not just out of the mind of Kernighan Ritchie, or let's say Strauss-Troop and others. These are actually the design limitations of what is possible to redefine. Okay. Any other question? No. Good. So let me, how much time do we have? 20 minutes. So let me quickly finish off the next module, which is actually very straightforward. I've been talking about namespaces. Namespaces is giving a name, global name to a set of symbols. So I will talk about these. Okay. It is, let's start with an example that is easiest. So we have been writing this using namespace std. So let's see what it means. So namespace is written exactly like the syntax you write your class or struct. So namespace is a keyword, and then you write the namespace name, and then within a pair of curly braces, whatever you write those names get qualified by the namespace name. So when you write my data here, int my data, then it's a variable in the namespace whose actual name, fully qualified name is, you can see in the main below, my namespace : my data. The function in the namespace, my function, becomes my namespace : my function. A class, my class, becomes my namespace : my class. And you know that the class itself is a namespace. So the name of this display function actually is my namespace : my class : display. Right? So that is the basic purpose of the namespace. So you can have as much of nesting of the namespaces as you want. It's beyond the resolution of the scope, that is, fully qualified name. All symbols in the namespace are in the global. They're actually global, but they are just having different names. So what kind of the use, it's it's kind of putting, you can say that it's kind of the sense of family name many part of the world has. So certainly my family name is Dash, and within that my name is Partho. Our last director, Professor Parthapratim Chakraborty's family name is Chakraborty. Within that, his name is Partho. Right? That does not conflict because you take it two different family names to make sure that all names within that family name are unique, and globally they don't conflict because you have different family names. Of course they do, because multiple families use same name, but that's not what is allowed in the programming space. So that is the basic purpose of the namespace. So I can show you some direct use for that. For example, let's say I want to write an absolute function. Now I want to write the absolute function to really mean something special for me. Right. So I'm saying that this absolute function is, if it is less than -128, it returns 0. Greater than 127, it returns 0. And if it is negative, it returns -1. So which means that between -128 to 127, I want to take the positive. I want to take every value and take it as a positive value. Outside of that, everything should be 0. Right? So that's whereas the fact of the matter is, standard library already has a function by the name of ABS, which takes an integer and finds out the absolute value of the parameter n. Right. So what happens when you do this? So here you get this output, which is what you are getting. So can you see what has happened on the left? Your ABS -203 has become 0. This is output, which is according to this function, which means that the function that you have defined has actually hidden the function that was originally there in the standard library. Now think about the case that this ABS function that you have defined is in some file, and the use of that ABS function is in some other file, which is very, very common, several other files. Now anybody reading this code will naturally not think that you have a different ABS file. She will think that it is the ABS file in the standard library because it's a very, very standard function. So C had to allow the kind of, I should not say overloading, but suspension of name mechanism with the standard library or with an existing name, because otherwise it is not possible to use the names that are already used in the standard library. C had that philosophy, but that's a bad philosophy. So by providing your ABS function, you have actually sacrificed the original ABS function. But in C++, you have a very beautiful solution. All that you need to do is create your own namespace and put your ABS function in that namespace. So it still remains global everything, just you are wrapping it with a namespace of my namespace, my NS. So now what happens? The name of this function is not ABS, it is my NS colon colon ABS. So if you use my NS colon colon ABS on the same set of values, you get the same output as you are getting in C after the hiding of the original name. But here the original name still remains to be ABS, and you can use that in the original sense. So now if you do ABS minus 203, it gives you 203 as it should. So both these functions remain available in the global, but you have created a very nice mechanism, and anybody reading this code will know that my NS colon colon ABS is a different function because you are using a different namespace name. So she will immediately go to that namespace and find out what this ABS is. So it improves readability. It gives you tremendous semantic clarity in terms of this. There have been, millions of hours wasted in debugging programs because of this problem. Because the designers have felt that, well, let me redesign the function from the standard library and give it the name so that it remains intuitively same. And later on, when a bug arose, the debugging developer never knew before spending a lot of time that actually the function that she's looking at is different from the standard library function. Proper use of namespace solves that problem. So use namespaces. This is a long example. You can look at this. I would just like to highlight one point, that suppose you're working on the same code base, and which is often true, is programming is at a scale in a project is not a single individual's job. There are multiple developers, and they are parallelly working on the code. Right? So it is quite possible that when you try to put these codes together, the two developers may have used the same name for variables or functions which are globally available. If it is a local variable, there's no problem, because local variables are always protected by the local scope. But if you suppose the Shobita and Niloy are developing on the same project, and both of them write a function in the global space called process students. Now they have independently done the development. Shobita has done it in her desktop, Niloy has done it in his desktop, and so on. So they did not have a problem. Now comes, now say a third developer, Purnima, she has to put these codes together because finally it is one single project. Now she has a problem because there are two functions by the same name, process student. And unless she can carefully edit every place where process student is used and give it a different name, say process student Shobita, process student Niloy, just for the sake of a name, and replaces it everywhere in the code, she will not be able to find a solution. And that gets really, really difficult. So what Shobita and Niloy could have done, which would have made things much easier, is to put them into a namespace that is specific to them. Say app1, and this case app2. And then write every global stuff within that. So in that case, all that you need to resolve is the fact that the namespaces have different names. Beyond that, every symbol inside that could have different or same name. It does not matter. They are taken to be different anyway because the name is qualified by the namespace name. So it's a very, very, I mean, this is not something which kind of academic projects will feel a requirement of. But when you go to the industry and you work on code bases which are, million lines, and maybe hundreds of developers have already worked, and 20 developers are concurrently working on that same code base, these kind of issues and this kind of protocols become very, very important, because that is a good way to keep, of course, your strategy first of all should be to avoid global symbols, but I mean, you still will need to have a lot of global symbols. So always put that in a properly decided namespace scope so that you do not have conflict. So that is the same thing which is done for the whole of the C++ standard library. The C++ standard library, in order to make sure that you do not get into the same issue as you got into C, because your ABS function is in the global space, and therefore nobody else can write the ABS function without hiding the original ABS function. C++ wanted to avoid that, of course, and therefore the whole of the STL, whole of the standard library, including STL, is written within the namespace std, which means standard. So we say that when we are writing cout, the name actually is std : cout. When you are writing endl, it is actually std : endl. Cin, std : cin, and so on. Now, naturally, it might become, I mean, if you have a lot of symbols being used from a namespace within a file, it might be very, tedious to keep on writing the namespace name prefix at every place. So you have a shortcut to say using namespace std. What it means that if you say using namespace std, then when you come across cout, it will look for cout in the global names as well as in the namespace std. Right. So using that, you cannot have another object called cout used in the same program. But other choice could be, it is up to you whether you can use this using stuff. You can drop this using stuff. If you do, then cout will have to be written as std : cout. But in that case, you have the choice that you can define your own global cout at your choice. So namespace give you name. I mean, we hardly realize, but name and naming convention and naming scope is a big issue in big projects. So you can put things in. So this for a good night's sleep, that you can put the two functions that Shobita and Niloy wrote, having the same name. Purnima puts them into two different namespaces and uses them from the different namespaces. Okay. Now, a couple of more things. Namespaces can be nested. You can have one namespace within the other. So you have namespace name1 scoping up to this, namespace name2 scoping up to this. So data has a name, fully qualified name, which is name1 : data. Data here inside. Otherwise, normally you will not be able to. There'll be clash of definitions. But here again, you are calling it data, but its name is different. It is name1 : name2 : data. Right. So you can have nesting of namespaces, and you can you can use using namespace. I have already explained, to avoid lengthy prefixes. Now, when you define things in the namespace, by default, at times you might want to use a name which is in the global space. Think about this. You have a data in namespace in name1, right? And you have used using name1 : data. So you have said that I'm using data from namespace name1. So now when you write data, it means this data, because you have a using. You are directly using this member, directly using this variable. If you say name1 : data, it again means this data. The question is, how do you get to the global data if you want to use it? There's a very simple solution. You just write : data. That is, there is no namespace. So your prefix part before the : becomes empty. So if you just write : data, it means a name which is in the global space. So that's how you can resolve between a namespace and the global space, because you often would also deal with projects which has a mix with C code, and C codes do not have namespace, so they write everything in global, and you may have name clashes with that. And when you want to access that name in the global, you have to use this convention. So namespace is something of a very, very convenient mechanism standard namespace. I have already discussed that. Another thing, unlike class, the namespaces are open in the sense that if you define a class, you have to define the whole of the class in one go. It is not so in namespace. It's kind of keep on getting added. So you have namespace open, you have written. Then you again write namespace open. So they will both belong to the namespace open. So it's kind of, you can keep on taking union. Both of them belong to the open. Okay. And finally, naturally, there are some similarities with the class. So you can obviously been able to see that namespace is just a naming convention. So it's not a class. Every namespace is not a class, but every class defines a namespace in the same way namespaces do. A namespace can be reopened and you can add more declarations, as we just saw. A class cannot be reopened. No instance of a namespace can be created. Namespace is just lexical. It is just for the program text. There's no runtime instance for that. A class obviously have multiple instances. Using declaration can be used for shortcut of namespace. There is no using like stuff in class. Namespaces may be unnamed. That is, I can just write namespace and within bracket, I can write this. I can just put a few symbols together. They will be accessed like the global. But unnamed class is not possible. So this is basically, so namespace has to do with basically the lexical scoping of a name, binding of the name. And as you know, these are the different kinds of scopes that you have in C++. You have an expression scope, which is restricted to one expression only. You have a block scope. You can have a local context. You saw that in PDS. You have a function scope, which again you saw in the PDS. You have a class scope now, which you have seen here. You have a namespace scope, which we can define. You have a file scope. Certain symbols are limited within the file. Again, this is not something that C++ likes, but C did have that. So you had a concept of a file static variables, which are static within the file only. So that still exists in C++. And you have a global scope, which is the outermost singleton. Now you understand singleton. This is a singleton scope because there can be only one global scope, but everything else could be in multiple. This contains a whole program. Right? So this is about the namespace. Then more details are given in the next slide for your reference, but I'm sure you have understood what is a basic principle of the namespace. Just let me ask if there are any questions.
Sir, I have a doubt.
Yes.
Sir, in this slide, when you are showing about the ABS function, if we write using namespace std and using namespace minus, then what will be the ABS? Which ABS function will be used?
The compiler will solve that problem. Compiler will this slide you are talking about, right?
Yes, sir.
Slide 6, right? Yes. If you this in C++, the left one is kind of a C style code. In C++, you can do using std, namespace std. Here you can do using namespace -. The compiler will say that I have a name conflict. That is advantage. Now in C++, it will say I have a name conflict. So it will warn you that you are doing something. You are bringing in multiple names in the same scope. Right? That's the advantage.
Okay.
And so,
Yes.
so I have a request regarding assignment 2. Sir, can you extend the deadline? So because yes, so because we have yesterday, so we have 2 tests and tomorrow also we have a test. So I don't think we can focus on that assignment in 3 days.
What is your name?
My name is Abhilash Datta.
Abhilash Datta. Abhilash, I can extend the date. I will. You are requesting, I will, because obviously it is for your learning. The question is not about getting an assignment done and somehow get a marks on that.
Yes, sir.
It's about learning, and this is something I consider this course to be very, very fundamental to everyone getting out of here with the undergraduate degree, because you must be solid in the computer science core part of it. But
Yes,
the
sir.
consequences which you have to keep in mind is there are 6 assignments to do. So more time you take on this side, eventually it means that there'll be less time on some of the later assignments. But well, you tell me how much. Tomorrow morning you tell me when you want the extended date. Will
So
one
just
day help?
2 days would be fine.
2 days would be fine. So from
Yes,
first, third would be fine.
yes, sir.
Okay. Okay. I will do it third. But please keep this in mind that we cannot regularly do this, because then it will
Yeah,
happen that assignment 5 and 6 will have to be done in 1 week, because I cannot change the grade submission date, which is fixed. Okay. So we are already crossed time. Thank you all very much. Tomorrow we will meet in the morning, and tomorrow I will start doing the second and possibly the most important aspect of object-oriented design, which is inheritance,
inheritance.
specialization. We'll start talking about that tomorrow morning. Thank you. Have a good day.
Thank you, sir.